Welcome students to the ACT Practice Test Part 5. We will be looking at numbers 41 through 50. Let's go ahead and get started. Number 41 reads as following. A Ferris wheel is turning at a constant speed during one of its rotations. Let t represent the time that has elapsed since the wheel started turning, and let h represent the height above ground level of a certain seat on the wheel. The seat is at its minimum height, lowest height, at t equals a seconds. And the seat is at its maximum height at t equals b seconds. One of the following graphs represents this relationship between t and h. Which one? Now, first of all, let's go ahead and do a couple of things. Let's understand that if you're on a Ferris wheel and you're in the seat right here, if it's turning, you understand, like right now, let's say the ground level is right here. And let's say you're 20 feet off the ground. As the seconds go by, like 1 second later you're here, 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 then here, then here. Do you see how the height is always changing? Every second, as long as the wheel doesn't stop, and as long as the wheel maintains a constant speed, which look at this first line up here, it says it has a constant speed, this seat is going to rotate around and be a certain height off of the ground, okay, as this seat goes around. This will be the highest point right here. You'll be way off the ground, way up there. Okay, so what they're saying here, this is a pretty tough problem. I'm going to tell you right now, it's not easy. Some of you will get it, some of you won't. But what they want you to do is to be able to look at a graph and interpret it and understand what it's saying. Now, if you've ever been on one of those really crazy rides that make you sick, they might shoot you up in the air, then shoot you down, then back up, then back down. Those kinds of rides are taking sharp turns. In other words, please watch this carefully. You're here, then a split second later, you're here. There is a quick, sharp turn, a quick, sharp change in your height based on time. It's not a smooth, rounded change. It's sharp, it's sudden. A Ferris wheel is not like that. A Ferris wheel is a smooth, rounded turn the entire time, giving you plenty of time to get sick. I'm kidding, but it's a smooth, rounded ride, okay? So the first thing you can do here is you can eliminate some of these graphs. Like right here, a model that's going to model a Ferris wheel turning is not going to be a graph that says, okay, we're here. And how about this one? There's no way that you stay at the same height for any amount of seconds. I mean, as long as this wheel is moving, your height is always getting lower to the ground, closer to the ground, or higher, further away from the ground. So there's no way that graph is it, and there's no way this graph is. Look at that sharp turn. It hits here, then all of a sudden you're shooting down here in a linear movement? And no way, not at all. So guys, they're just really testing your ability here to understand graphs and to use common sense and read them and understand what the graph is saying. And all the graph is saying is, hey, give me a certain time t and I'll tell you how far they are off the ground, as long as I know the speed of the wheel and all of that. So it's going to be one of these two. Now look what it says. This is really pretty simple. Right here, the seat is at its what height? Minimum height at t equals what? A. So let's look at these two graphs. Here, when we get to t equals a, the graph's way down here. Here, when we look at a, the graph's way up here. Now, common sense would tell you which one of these is showing you a low minimum height when t equals a. This one is. This is showing you that at the time of A, you're at a maximum height, and that's not correct. So this is the right answer, okay? Smooth rounded turns like that, and when t equals a, you're at your minimum or lowest height. And by the way, you're at your maximum height when t equals b, and here's b, and we're at our maximum height, okay? Not too bad. And what are they teaching? What are they testing you on? Again, your understanding of graphs, reading of graphs, knowing what input output is when you have a certain t, you have a certain h, and being able to understand that. Number 42, in the line below, X and Z are on line M and Y is on line L. The exterior angle to X, Y, Z at Z the exterior angle to triangle X, Y, Z at Z measures 160. One of the following statements will give us sufficient additional information to find the measure of angle B. Which one? Now, let me tell you right now what they're testing you on. Are you ready? And you know what? Here's the thing. Before I tell you what they're testing you on, the problem with this problem, if you will, is there are so many geometric principles. I mean, how can I say study this list of objectives? And there's just so many they could throw at you. But some of the basics are the sum of the interior angles of a triangle is 180. Another basic one would be the sum of the interior angles of a quadrilateral. A four-shaped object is 360. Here's the one they want you to use on this problem is whenever you take one side of a triangle and extend it, we call that an exterior angle, and it's 160 degrees. And what you need to remember is this angle here, I guess they're using E and B, so I'll use E and B. E and B. These two angles here will always add up to this angle here. Always. So if you're ever given an exterior angle of a triangle, and you know one of these angles here, like let's say this is 30 degrees right here, then you know this angle here has to be 130 because these two interior, they're called remote interior angles. These two remote interior angles will always add up to, or their sum will always equal this exterior angle out here, always. So that's what they're kind of wanting you to remember in this problem. So let's go ahead and apply that now. What additional information, which one of these options down here gives us sufficient additional information to find the measure of angle B? Now here's the measure of angle B, right? And don't we know that this angle here is 160, correct? And what did I just tell you? If we add E and B together, put a plus sign here, if we add these two angles together, I'll get 160. So what piece of information do you think I would like to know that would help me solve for B? Well, yeah, you guessed it, E. I mean, if I know what E is, then I can easily find B because these two have to add up to my exterior angle, which is 160. Well, do any of these comments down here help me find D or help me find E? Students, this one does right here. This is such a great problem because another thing they're testing you on is, do you remember when you have a straight line and a line coming off of it? We'll call this angle 1 and angle 2. Anytime you have a straight line with another line or segment or ray coming off of it, these two angles here will always add up to what? Always 180. They are what we call, remember this word? Supplementary. They're supplementary. So look how you have a straight line here. See that straight line? And then we have a line coming off of it right here, correct? Well, look at option C. If I know the measure of angle D is 130, students, if that's 130, then I know E has to be what? 50, because these two angles have to add up to 180 because we have a straight line with a line coming off of it. And as soon as I know that's 50, then I know B has to be 110, right? Because these two angles here have to add up to 160. So the important piece of information that really would help me in this problem is G right here. As soon as I know the measure of angle D, that's really going to help. Now, it might have been helpful to know that L is parallel to M, and it might have been helpful to know the measure of angle C, although I really don't know how C's congruent to F. Or equal to F. That might have helped in the long run with a bunch of playing around with it. Or the measure of A, angle A is greater than the measure of C. But the bottom line is this, that's the best answer. And they're looking for the best answer. As soon as you know what D is, you know what E is, you know what B is. So again, they're testing your ability to remember whenever you have a triangle, if one side is extended, this angle here, X, is going to be equal to Y plus Z, these two angles here on the inside. And they're also testing your ability to remember if you have a straight line with the line coming off of it, these two angles here and here are always going to add up to 180. Okay? Okay, moving on to number 43. Now, in the figure below, C lies in the interior of the acute angle ABD, so we can see that, it's pretty obvious. D lies in the interior of CBE, that's pretty obvious. The measure of ABE is 75. So this whole angle right here, this whole angle ABE is 75, okay? So let's not forget that. I'm actually going to write that over here. Kind of draw the angle a little bit. So that whole big angle, A, B, E, is 75 degrees. Now, what else do they tell us? The measure of ABC is 25. They wrote that for us right there, so it's already in there. And the measure of DBE is 35. Here's D, here's B, here's E. So D, trace it to B, trace it to E. That angle is 35. They've already given that to us right there. What is the measure of angle ABD? They want to know the measure of this angle here. A, then B, and then D. Now students, come on, think this through. Let's pretend this angle here was 20. I'm just making that up. If I knew that this angle right here was 20, could I not add 20 plus 25 and know that that whole angle is 45? Could I not do that? Sure, I could. So if I want to find the measure of angle ABD, then really what I got to find is this angle right here. And students, isn't that pretty easy to do? And by the way, they're testing your ability here to remember angle addition. And we did a problem earlier in one of the earlier ACT videos. It was segment addition, where I think we had a point here and a point here and one way down here, and they said the midpoint, like this was, I don't know, 10, and from here to here was 20, and the midpoint is here, and what's the distance from here to the midpoint, and we had to use segment addition. Well, now they're testing your ability to understand angle addition. Okay, so let's see if we can figure this out. What does this whole entire angle have to equal? 75. Well, this much is 25 and this much is 35. So all that I have to do is figure out what this little angle is right here, where this dot is, to make all of this add up to 75. Now 25 plus 35 is 60. So that means this little angle right here has to be 15 degrees. It has to be, because 25 plus 15 plus 35 would give you 75. And this whole angle, it says right here, ABE, the whole angle is 75. Now that you know the measure of this little angle right here, that little angle right there, let's go ahead and answer the question. What is the measure of ABD? Well, here's A, here's B, and here's D. Add those two together and you'll get 40. The answer is 40 degrees. Now, again, they're teaching you angle addition. They're teaching you reasoning skills. They want to see if you can see what the whole sum is, and then find out what that missing angle right there would have to be, and then go ahead and add those two angles together to find the complete sum of these two little angles here that make up this angle. Okay, so that's what they're testing you on. All right, number 44. Now this is going to be a tough one. I'm probably going to have to open up another page here and go back and forth. There's just not a lot of room. Okay, the problem reads, Lee is standing at point L, so here's point L, on the north side of the small canyon in the figure below. As measured by line of sight, Lee is 2 miles from T, and that's drawn for us right here. And she is 3 miles from the scenic overlook S, and that's drawn for us also right here. So 2 miles from T, 3 miles from S. Okay, so here's your 2 and here's your 3. Lee, the observation tower, and the scenic overlook are all at the same elevation. The measure of S is 28 degrees. Which of the following equations, when solved, gives the measure of angle T? Now students, listen to me. You should have had something in geometry or advanced math or pre-calculus called the law of sines, or the law of sine, however you want to say it. And it was something like this: side A over the sine of A. And by the way, if you're in geometry this year, as a senior, you'll get this later, okay? There we go. Now that's called the law of sines. This is a pretty hard problem, okay? So some of you will get it and some of you won't. Now, look, what they've done in this problem is very unique. They flipped all the fractions, which is no big deal. Look, if I told you this fraction is equal to this fraction equal to this fraction, and you want to flip this fraction, you're more than welcome to do that as long as you flip all the fractions. So what they did is they took the law of sines and they flipped it. And that's no big deal. We're okay with that. So they put the A in the bottom like this. They put the fraction bar right here. So I'm going to quickly move all this around. So that's what they've done. No big deal. Kind of unorthodox, but that's fine. Well, that's not going to work, but there we go. Okay, so that's what they've done. So step one, let's pause and review. If you've never had law of sines, then you're going to be a little confused. So just kind of sit back and listen and take some notes, and you'll get the law of sines eventually. Number two, if you have had the law of sines, you should have noticed that they had all the fractions flipped right here, which is no big deal. You can do that as long as you flip all of them. No big deal. Okay? And then lastly, notice what they're asking for. Which of the following equations, and here's your list of equations you're going to look at right here. Which of the following equations, when solved, gives the measure of angle t? Now, what you're taught, and again, a lot of you might not have had this, but what you're taught when it comes to the law of sines is you're looking for a pair. You're looking for an angle and the side opposite that angle. And notice how we know both of those. We know the measure of this angle and we know the measure of that side. So we're going to use those two numbers and we're going to write down sine of 28 over 2. Let me make sure that's right. Yep, sine of 28 over 2. Do you see that okay? This might be new, but that's what you do. You look for an angle and a side that's across from it, and make sure you know both measurements of those, and then you write them in a fraction. Then you put equals. Okay? And then you look for, or you ask yourself, what am I solving for? I'm solving for the measure of angle t. So if I'm solving for the measure of angle t, this will be my unknown, then that means I need to use, let me clear up some of this mess here. If I'm solving for angle t, then the side that goes with angle t would be the side directly across, which is a 3. So just like the 2 and the 28 went together like that, t and this side over here go together. So I'm looking for angle t, and I'm going to use side 3 to help me. So I'm going to say side 3 over, now it's angle t, so I'm going to take the sine of angle what? T. Now again, if you've not had law of sines, you're going to be pretty confused. We'll get to that later for some of you who have not had it yet, but that is how you would use the law of sines. Now I'm going to pull this up here, and we're going to, sorry about that, we are going to simplify this and see if we can get one of these to look like our answers on the previous page. Let's go ahead and take a look at our answers. Maybe they have an answer like this already. Maybe this is one of our options. Let's see. And it might be actually, let's see. Ah, there it is. I think they had it for us already, so I'm glad I didn't waste time and go into great detail. Oh, no, they did not. Sine of 28 over 2, sine of t over 3. Let's see here. Here it is right here. Letter F. Sine of t over 3, sine of t over 3 equals sine of 28 over 2. Equals sine of 28 over 2. So there it is. So your answer would be letter F. Okay, now that's, again, if you've had law of sines, it might have been a while, but at least it rings a bell a little bit. But that is how you would solve that problem. Okay. All right, number 45. Number 45. So what are they testing you on previous there? They're testing your remembrance, how well you remember the law of sines, how to set it up, and how to use it. Okay. All right, number 45. Mr. Green is buying mulch for his triangular-shaped garden. When the mulch is uniformly spread 2 inches deep, each bag of mulch will cover 12 square feet. However, though, Mr. Green wants to spread his mulch 3 inches deep, okay? So which of the following is the closest to the number of bags of mulch Mr. Green will need for his garden? Now look, to me it's common sense. There's no way we can solve this problem until we know the area of the triangle. We have to find the area of the triangle. So if you'll think back to your formulas for area of a triangle, it's 1/2 base times height. 1/2 base times height. So the area of the triangle would be 1/2 times 26 times 10. And you would get out 130 square feet. All right? So the area for this triangle is 130 square feet. Now that helps a little bit. Now let's go back up here, and what you would do in a problem like this is, first of all, they're testing your ability to remember how to find the area of a triangle, and then how to just reason and think this through. Just use common sense and reasoning skills. For example, we know that one bag, now watch this carefully, one bag will cover how many square feet? 12 square feet. However, that's going how many inches deep? 2 inches deep. Okay? Do you see what I'm saying there? Now, and it says that right here. One bag will cover 12 square feet, 2 inches deep. Okay? Now, I want to go 3 inches deep. Now, see if this makes sense, guys. Watch this. Do you see how one bag would cover 2 inches? Well, doesn't that make sense then that a half a bag would cover only 1 inch? That makes sense to me. I mean, if one bag covers or goes 2 inches deep, then a half a bag would go 1 inch deep. That makes sense to me. So basically what I'm looking at is this. I'm simply saying this. If one bag will cover 2 inches deep, then all I have to do is add a half a bag. 1.5 bags will still give me 12 square feet, but now it'll go how many inches deep? 3 inches. And that's what Mr. Green wants. He wants to spread his mulch 3 inches deep. Okay? So that makes sense. I mean, think about it. If one bag will give you 12 square feet, 2 inches deep, I mean, 2 bags would be what? 4 inches deep? Sure. So going in between, 1.5 bags would give you 12 square feet, 3 inches deep. And that's what I want. That's exactly what I want. So I'm going to make a quick ratio and just solve this. I'm going to say, okay, for every 1.5 bags, I'm going to get how many square feet? 12 equals how many square feet do I need to cover? 130. So how many bags would I need? That's my X. Notice I kept bags up top, area in the bottom, or square feet in the bottom, square feet in the bottom. So what I said is this. If 1.5 bags, or let me read it backwards. If 12 square feet requires 1.5 bags, then 130 square feet would require how many bags? And of course, you should remember from your early days in math, just cross multiply and divide. 12 times x right here, 12 times x would be 12x. And then 1.5 times 130 would give you, I think, I'm doing it in my head, it should give you 195. Let me quickly check that while I'm talking. Yep, 195. So 1.5 times 130 is 195. And then divide that by 12. Divide both sides by 12, and you'll get 16.25. 16.25. Now, notice none of the answers there are 16. Do you see that okay? And that's okay. It says, which of the following is the closest? So they've tested your ability to find the area of a triangle. They've tested your ability to problem solve, where if one bag is going to give you 12 square feet, 2 inches deep, but he wants 3 inches deep. How are we going to correct that? Well, we corrected that by making it 1.5 bags. Will give us 12 square feet, 3 inches deep. And they tested your ability to use ratios or some form, some way, to some method to solve this. And now they're testing, can you use common sense and see which one of these numbers is closest to 16.25? Well, it's obviously 17. That's the closest number out of all 5 of these to 16.25. Okay? All right, I hope that's been a help. Let's take a look at number 46. Okay, this is a really good problem. A child's dose of medicine is often based on an adult's dose. For some medicines, Cowling's rule, and I've never heard of that, but I'm sure it's for doctors and pharmacists. Cowling's rule would be D equals, and then capital D, A plus 1, all over 24. And this relates the dose D of milligrams for a child of age A years to the adult dose of D milligrams. Which of the following expressions gives A in terms of D and D? Now, first of all, you need to understand what this means, A in terms of D and D. Okay? Can I give an example, please? Area of a triangle equals 1/2 base times height. You know what that means? That's A in terms of B and H. If I said the perimeter of a rectangle is 2L plus 2W, this would be P in terms of L and W. Are you getting what I'm saying here? If I said the circumference of a circle is pi d, remember pi is a number, I would say this is C in terms of D. So when they ask you when they ask you, hold on 1 second, please. When they ask you to give A in terms of D and D, that means they want you to get A all by itself in such a way that the only two variables you have over here are D and D. Now there can be numbers, that's fine, but A has to be all by itself, A in terms of D and D. So that's what that expression means. A in terms of D and D means A all by itself with D and D on the other side. So what they want you to do is simply take this formula and get A by itself. Now here's the first thing I would do. See this 24 in the denominator? I know if I take this whole side and multiply it by 24 over 1, it'll cancel out my 24s. But if I multiply one side by 24, I must multiply the other side by 24. So now I'm left with 24D equals, these cancel, D parentheses A plus 1. Now let me explain that another way. If I had 2x equals 6, the 2 and the x are multiplying, right? And the opposite of multiply is divide, so I divide both sides by 2 because we use the opposite operation. Well, let me ask you a question. What is this 24 doing in the denominator? Isn't it dividing? Sure it is. And what's the opposite of divide? Multiply. So I'm going to multiply both sides by 24 to get rid of it. Now, I still don't have A by itself, but notice I have D times this whole group. Well, D is being multiplied by this whole group, so if I divide by D, that'll get rid of my D, but if I divide one side by D, I must divide the other side by D. Now please don't cancel these D's out. One is capital, one is uppercase, one is lowercase, so they are not the same variable. Do not cancel them out. So now I have 24 little d all over capital D equals A plus 1. And now simply bring the 1 over and make it a negative 1. Bring the positive 1 over and make it a negative 1. So 24 little d over capital D minus 1 equals A. Alright, now they don't have the equals A, but they're going to have this formula somewhere. Here it is right here. Letter H. 24d over d minus 1. Pretty cool. All right, let's continue on and take a look at number 47. Oh, my fault. They're testing your ability here, and we did this in Algebra 2 and Algebra 1, to solve abstract equations, or I like to call them multivariable equations. And that's really all they're testing your ability here is, can you solve multivariable equations? Can you isolate a variable when you have more than one variable in the equation? And that's something you should know how to do. All right, number 47. Now guys, I'm going to quickly give you a list of logarithmic properties you need to be familiar with. Are you ready? Okay, the log of x times y, and I'm going to put arrows pointing both directions because it goes both ways, is the log of x plus the log of y. Okay? And the logarithm of x divided by y is the same thing as the log, and you take the top of your fraction and then minus the logarithm of your bottom fraction. And then one other thing that you should have learned is log, and I guess we'll call this base A. I should have given it a base, so we'll put base A's here because they do have to have the same base. If I have log base A of B with C as an exponent, that's the exact same thing as moving the C to the beginning of the logarithm like that, and it would look like this: C logarithm base A of B. Now, if you've not had this in Algebra 2, or if you've had it and you've forgotten it, I'm just reviewing. Remember, the goal of an ACT practice test is not to teach you what you haven't learned, is to review what you should already know. And so this should be review. If not, there's no way this would take a couple days to go over in a regular math class, but this should look familiar. When your argument is multiplying, like these two are, you can split them up into two logarithms as the sum of two logarithms. If your argument is dividing, you can split it up into the difference of two logs. And if you have a power here, you can move it out front, or vice versa. So with that in mind, they want us to take this expression and simplify it. So here we go. I'm going to take this equation and write it down here, or not equation, this expression, log of 2 x to the 1/2 power. Now, the first thing you need to know is there's really a 1 here, even though you can't see it, and really a 1 here. So I can multiply the 1/2 through, and now I would have the logarithm of 2 to the 1/2 power x to the 1/2 power, because 1/2 times 1 is 1/2, 1/2 times 1 is 1/2. Now, next, what did I show you up here? When you have an argument in which there's multiplication, you can split it up into the sum of two logarithms. So 2 to the 1/2 times x to the 1/2 would be the same thing as this right here. All right, so the log of 2 to the 1/2 power plus the log of x to the 1/2 power. Okay, and now what did I teach you right here? What did I review? Whenever you have a power, you can move it out front. Okay, so if I move the 1/2 out front, I would have 1/2 log of 2 plus 1/2 log of x. There we go. There we go. Now, that would match letter D right here. And so there's the answer. Okay, so we're just reviewing logarithmic properties. These are the basic ones you need to know right here. I mean, there are some other ones I could throw at you, but these are the basic ones you need to make sure you're familiar with. These are really, really important to know. They could throw all kinds of different types of logarithmic problems at you like this, so make sure you know these properties. All right, number 48. All right, now the first thing you want to do in a problem like this when you're taking the ACT test, first thing I always do is I just stop and I go like this. I just split the two triangles up. I mean, I've got a little triangle right here. That's this one right here. And I've got a big triangle right here. And that's this one right here. Okay? Now, my little triangle has a length of 16 right here. Do you see that? It has a length of 8 right there. So I'm going to go ahead and put an 8 right here. Now I know the length of this whole side right here because from here to here is 16 and from here to here is 12, so I know this whole length right here has to be 28. So this whole length right here is 28. Now something else you need to know, and please listen to me carefully. Please listen to me, whenever you have a triangle drawn within a triangle like this, like they start off with a triangle, then they put a line like this. Whenever this line right here is parallel to this line here, then these two triangles right here, the little one and the big one, they're not congruent, obviously, but they're similar. They're similar. And what that means is their sides are in proportion to each other. And how do I know? Do I know that this side here is parallel to this side here? Let's go ahead and read the problem. Let's find out. In triangle ACD, BE, here it is parallel to CD. Here it is. So we do know they're parallel. And the given lengths are in feet. Given that CD denotes the length in feet of CD, which of the following proportions involving CD must be true? So in other words, which of these proportions over here would help us solve for CD? Well, I think it'd be very helpful, and I should have done this right away. I'm going to label these vertices. This is A, this is B, this is E, and this is A, and this is C, and this is D. Now it says we're looking for CD right here, okay? Now, think about this. If these two triangles are similar, which they are, I can say 16 over 28 equals 16 over 28 equals 8 over side CD. Now, I did know this was going to happen, okay? When I come over here, I don't see any of these matching. This one almost does, but it doesn't quite work. So what am I going to do? Well, I'm showing you both ways just so you're familiar with this. Look, don't forget that when you're writing proportions, there's more than, or ratios and proportions, there's more than one way to do it. You can definitely say as 16 changes to 28, 8 changes to CD. But there's also another way you can write it. You can say this right here, 16 over 8, 16 over 8 equals Now 16 was first up top, so 16 over 8 equals 28 over CD. You can definitely say that. Now let's see if that matches anything over here. 16 over 8. 16 over 8. Here's 16 over 8, but it does not equal 28 over CD, so that's no good. I don't see any 16 over 8s. Maybe they flipped these two. Sorry about that. Maybe they flipped these two. Maybe they said 8 over 16 equals CD over 28. That would be the same thing. You can flip this side as long as you flip this side. Let's see if that works. And there it is right here. 8 over 16 equals, no, that's not it. Sorry about that. 8 over 16 equals CD over 28 right there. Okay, now let's review. What they're testing you on here is a geometrical principle that whenever you have a triangle written within another triangle in such a way that this side here is parallel to this side here, then the two triangles will always be similar. And if they're similar, then you know their sides are in proportion to each other. Or in other words, corresponding sides are proportional to corresponding sides. So I could say 16 over 28 equals 8 over 16 over 28 equals 8 over CD. That's totally awesome. That's fine. But it didn't match any of these. So you can also say 16 over 8, which is this, equals 28 over CD. Now none of these answers match this one. So I said, okay, I'll flip each side. So I can flip this one and flip this fraction, and then it finally matched. So this is a really good problem here for you to understand similar triangles and proportions, okay? And you need to know there's so many, I mean, how in the world can anyone, express to you every single geometrical property or principle that you've learned? Every single one of those you need to know for the ACT test. It's not possible, but know the basic ones, and this is truly one of the basic ones, okay? All right, moving on to number 49. Number 49. Now this will be a problem that a lot of you probably have never seen before, and you probably never will if you're not going to take advanced math or pre-calculus. But let me very quickly give you a model and some things you might need to know. I would encourage you to copy this down. A equals, let's just say, I'm trying to think of different letters to use. We'll use C. C plus A sine of bx, this whole thing, and we'll say minus D. Now some of you might want to take notes on this, some of you might not. That's fine, it's up to you. If there's ever a sine function where there's a number all out front here, a term by itself, it's a number, just so you know, in case they do give this to you on the AC test, that's going to be a vertical shift. A vertical shift. Again, if you've never had this, at least you can memorize this, and it might get you a correct answer, or at least it gets you close enough to make an educated guess on a problem like this on the ACT test. This number here would be your vertical shift. If it's negative, you're going to go down. If it's positive, you're going to go up. This number here, this right here, is going to be a horizontal shift. Okay, a horizontal shift. And then this number here that's being multiplied times your sine, or your cosine, that's always called your amplitude. And what it is it's your height from the middle of the graph. So see how this curve goes on and on and on? From the middle, I mean, if I were to draw a line right down the middle and cut it in half, so half of it's up top here and half of it's in the bottom like that. The amplitude is how high it is from here, from the highest point down to the middle, as high as it's going to go. And that is what we consider the amplitude. Now, if you've never had this, it's not going to be easy for you to understand. I understand that. I'm totally fine with that. I'm just trying to throw together some ideas here and maybe help you if you've never seen this. For those that have seen this, you should notice then right away when they say the graph of y equals a sine bx, which is what we have here, is shown below. One of the following values is equal to a. Which one is it? Well, I just told you whenever a number or a variable is in front of sine, that's your amplitude. So here's 1 and here's negative 1. It looks like the graph at its highest point goes to a half right here, up a half, and the middle of the graph is at 0 right here. So it looks like the height from here up to here is a half. It's a half. And it looks like the height going downward, if you want to call it a height, is a half. So the amplitude, hopefully you're seeing this okay. So from the middle of this graph, if I were to draw an imaginary line here, the graph goes up a half and it goes down a half, so your amplitude is a half. And that's how you know that answer, okay? Because whatever this is in front of your sign, that's going to be your amplitude, how far up and down you go. And looking at the graph, you can see you go up a half and down a half, so the answer is 1/2. Now, what are they testing you on here? Well, they're testing your ability of understanding your sine cosine models, okay? And a lot of you probably haven't had that. And some of you in your senior class this year are taking advanced math for the first time or pre-calculus, so you'll get to this eventually if you've not gotten to it already, depending on what scope and sequence your math classes go, okay? But that is what they're testing you on here. All right, number 50, and we're finally done. This is a good basic statistical question, and I'm not going to be able to give you a whole lesson or a whole class period on what it means by the normal distribution curve, but I will simply say this. If you know nothing about statistics, and you could read this and just use common sense, you could figure this problem out. I mean, you really could. Let me show you what I mean. Okay, let's see. Let me get my pen working here. Okay, suppose that the heights of men in a certain population are normally distributed. That means we're going to use the normal distribution curve. So we're going to use this curve here, and we know that because it says the heights of men are normally distributed with a mean of 69 inches. So that means the average or the mean is 69 inches. Now, again, if you know nothing about statistics and you can just read and understand words and use common sense, you can figure this out. The heights of the men of a certain population are normally distributed with a mean of 69 inches. So here's your mean. So right in this area here, 34.1% of the men have a height of 69 inches in a normal distribution, and a standard deviation of 2.7 inches to the nearest 0.1%. Now, standard deviation, I'm not going to give you a huge long definition, but it's the deviation that each number in your list of raw data that you have, it's how far it deviates from the mean. And then you take all of those deviations and you find a standard deviation. And in this situation here, a normal distribution with a mean of 69 inches and a standard deviation of 2.7 inches to the nearest 0.1%, what percent of men in the population are at least 74.4 inches tall? Now let's think about this for a second. If one standard, here it is, if one standard deviation is 2.7 inches, now again, if you can just read and think here, here's where the mean, the average falls right here, okay? Now once you start to deviate one standard deviation, that's that whole space in there, okay? Because think about it, people are not going to either be 69 inches or add 2.7, 71.7. There's going to be a gradual increase or decrease. So when it says right here, please watch this, and this will make sense to you. When it says one standard deviation is 2.7 inches, that means it starts to deviate here. Here's all the mean. This is all the average people right here. Their average height is 69.0. That's 34.1% of the people. And then it starts to deviate a little bit, and when it hits here, it starts to deviate, and then one full standard deviation is 2.7 inches. Then another full complete standard deviation is another 2.7 inches. Well, hold it. What's the average? 69 inches. It says what percent of the men are at least 74.4 inches tall? Well, 74.4. If you subtract, you're going to get exactly 5.4. So the difference between the average to the person you're comparing the average to, 74.4, is 5.4. Hold it. That's That's 2 standard deviations. One standard deviation is 2.7, and they set it up like that on purpose to make it easier. One standard deviation is 2.7. We have a 5.4 difference between the average height and the person that we're evaluating, or the group of people that we're evaluating, at 74.4 inches. So if the difference is 5.4, that's 2 standard deviations. And so that means we go all the way from here all the way to here. Now we're just estimating. We don't have a table to look at to help us. But if this is 2.2, and obviously the percentages here are going to range, are going to change, but the closest one here, students, is going to be right at about 2.3. Right at about 2.3. Okay? All right, interesting statistical problem there, but just pretty much reading and understanding what a normal distribution curve is. Okay, all right. Hope this video has been a help to you. One more video to go, and we will have covered the entire test.